All right, so we have f of x equals 2x to the fifth minus 15x to the fourth plus 34x cubed minus 15x squared minus 18x. And we want to write this from standard form into factored form. So the first thing I'm going to look for is a GCF. I notice that all of my terms have an x, so I'll pull x out. So dividing each term by x gives me 2x to the fourth minus 15x to the third plus 34x squared minus 15x minus 18. So looking at what I have left, I do not have an even number of terms, so it's not groupable. It's definitely not set up like a quadratic, so I couldn't factor it like a quadratic. So to factor this, my only option really is to go look for the possible rational roots. So looking at all the factors of my constant, so these are all my p's, and all of the factors of my leading coefficient, so my q's. So the factors of 18, I'll have 1, 2, 3, 6, 9, and 18. And the factors of q, being 2, are just 1 and 2. So the possible rational roots will be each p divided by each q. So all of my p's divided by 1, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. And then each p over 2 will give me plus or minus a half. 2 over 2 is 1, already in my list, so I won't include it. 3 over 2. 6 over 2 is 3, already in my list. 9 over 2. And 18 over 2 gives me 9, which again is already in my list. So this is my complete list of possible rational roots. And I want to go through and see which ones are actual zeros or roots. So I'm going to, I'll start with positive 1. I like 1. I'll start with positive 1 and plugging it into the original function, just seeing what gives me 0. So f of 1, plug that into my calculator. What do I get? Negative 13. I do not get 0. So I know 1 is not a root. So I'll go to negative 1. Again, plugging that into my calculator. I again do not get 0. So I know negative 1 is not a root. So let's go to negative 2. Plugging negative 2 into my calculator. Again, I do not get 0, so I know negative 2 is not a root. So I'll go to positive 2. If I plug in positive 2, I do get 0, so I know 2 is a root. So I can use this now to divide my polynomial to give me some factors to work with. So I like to use synthetic division, so I'll actually use the root. So I'm going to divide by 2, so 2 on the outside. And plugging, taking each of my coefficients. So I have 2, negative 15, 34, negative 15, and negative 18. So there's my setup for synthetic division. Bring down my 2 and multiply. Add gives me a negative 11. Multiply gives me negative 22. Adding gives me 12. Multiply, I get 24. Adding gives me 9. Multiplying gives me 18. And adding gives me 0. I should get 0 for the remainder because I know that 2 is a root. So what I have left, I started with x to the 4th power. So this knocked my polynomial down to x to the 3rd power. So I now have my x still on the outside. So I have f of x is equal to x times, if 2 is a root, then x minus 2 is my factor, times what I have here. So this is 2x to the 3rd minus 11x squared plus 12x plus 9 And so I'm going to look at my cubic now and see, can I factor it? I do have 4 terms. So is it groupable? Negative 11 over 2 is not equal to 9 over 12, so it's not groupable. So I need to continue on looking for roots. So I know 2 is a root. Remember that we can have repeated roots, so I'm going to check 2 again. So I'm going to work with now my cubic to try and reduce it down to a quadratic, something that I can actually work with. So I'm going to go back to my possible rational roots. I still know 1, negative 1, and negative 2 are not going to work, but I'm going to try positive 2 again, plugging it in right here. So I'm again going to go to my calculator and plug in 2. And see if that equals to 0. If we plug it in, does not equal to 0. So I know 2 is not a repeated root. So let's go to 3. So if I plug in 3, and again, you can just stick this in your calculator. And when I stick it in to the calculator, I do get that this is equal to 0. So I know now that 3 is also a root. So I'm going to go back to my synthetic division. I'll have 3 on the outside. And just working with this cubic, putting in my coefficients, I have 2, negative 11, 12, and 9. Bring down the 2, multiply, and add, multiply, and add, multiply, and add, and again, I get 0, which I should because we know that 3 is a root. And so I started with x to the 3rd power. So doing synthetic division has reduced it down to x squared. So taking everything into account now, looking back, I have f of x equals the x that we factored out, the GCF, the x minus 2 from the first root we found. And now I know 3 is a root. So x minus 3, and what I have left here, 2x squared minus 5x minus 3. So I have something linear, 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 and a quadratic. So now that I've reduced it down to a quadratic, I could look and see, is this factorable? If it's not, I could use quadratic formula, I could complete the square, couple of different options to be able to find the zeros of this. I do see that it is factorable, so I know that 2x times x will give me 2x squared, so I have 2x here and x here. And the factors of negative 3 are either negative 3 and positive 1 or positive 3 and negative 1. And combined with the 2, I'm trying to get negative 5. So if I do 2 times negative 3 and 1 times positive 1, 2 times negative 3 gives me negative 6. 1 times 1 gives me positive 1, and negative 6 plus 1 gives me negative 5. So these are the factors of 2x squared minus 5x minus 3. Bringing down everything else that I had. I see that x minus 3 is a repeated factor or a repeated root. So I can write this as x times x minus 2 times x minus 3 squared times 2x plus 1. And now I have fully factored my polynomial. There we go.